So I'm going to go over some of these that's going to be on Delta Math today. Some of this you've already seen before, but it's always good to get a little refresh. So first let's go over the translations of figures graphically. If you translate the figure 1 unit right and 4 units up, that just means every point. So 1 right, 4 up, go to this point, 1 to the right, and then 1, 2, 3, 4 up. You could have saw that it was straight across from there too. But here we go, 1 up, 1 to the right, 1, 2, 3, 4 up, 1 to the right, 1, 2, 3, 4 up, and then again 1 to the right, and then 1, 2, 3, 4 up. That's all you have to do for every one of those. Submit the answer, and I got it correct. So that's that whole section. It gives you that little animation. I went through that quick because we've done it before. Let's talk about translating a single point. This is what is the image point of 2, 7 after a translation 4 units left, or left 4 units and up 2 units. So left 4 units, left and right, we talk about the x number. Left goes down, right goes up. So that means 2 minus 4 will be our x value. So 2 minus 4 is negative 2. 7 is our y value. Up and down is the y value because the axis goes up and down. It says go up 2 units, so you're going to add 2 to 7 and make that 9. Again, we've done this kind of, we've already done it before, so I'm going to go a little bit quicker. This even shows you after you answer it, or even if you get it wrong, whatever, it's going to show you what happens. X minus 4, y plus 2. This is what the translation looks like if you write it out on paper. And then you would go ahead and plug that stuff in to get your actual answer. Points reflected over an axis graphically. So points over an axis graphically. It's exactly what it sounds like. It says the point J is plotted on the coordinate grid below. Plot the point J, and then we'll just call it J apostrophe. The reflection over J, or the reflection of J over the x-axis. So basically it just tells you J over the x-axis. This is the x-axis, goes left to right. J is here. So what we want to do is see how many boxes between here and the x-axis, and then keep going the other way. That's one way of doing it, and then we'll talk about the other way. So if we go 1, 2, 3, 4, 5 boxes, we get back to the x-axis. So let's go 5 the other way. 1, 2, 3, 4, 5. I could click it there. The other way of looking at it, and it makes more sense when I put the numbers down here, the x value stays the same when you reflect over the x-axis. The y value, you just change the sign. This was negative 5 on the y value. Now it's at positive 5. That's for reflecting over the axis now. It's got to be the axis to be able to do that. If you reflect over the line of y equals negative 3, you can't do that. So we'll talk about that later. But right now, the coordinates of J, the original point, is negative 4 and then negative 5. Our new point, we still have negative 4. But now the negative 5 has changed to positive 5. And just to really, drive that home, it gives you that point. It says when a point is reflected over the x-axis, the y-coordinate changes sign. You would hit submit, and then you do the same thing no matter what your point is. It might have you over the y-axis, but this is how you do this lesson. You just reflect it and then answer the questions below. Well, let's see what happens. Reflect the figure over a line. Now this is a figure and it's going to reflect it over a line. It says over the line x equals negative 5. This is the line of x equals negative 5. It's already got it there for you. So it's really easy to reflect it. You just kind of got to count the boxes again. So I've got from this point to the line is 1 box. So I'm going to keep going along that same line, 1 box. Up here I've got 1, 2 boxes from this point to the line. So on the other side, I'm counting 2 more boxes. And then right here, I've got 1, 2, 3 boxes. So I'm going on the same line and count 1, 2, 3 boxes. And that's reflected over that line. So I would submit answer. And there you go. Notice how it shows you that it flips. It shows you the animation. That's what I love about Delta Math. It shows you the animation of it actually flipping. And see, it kind of slides and then hits that line and then it flips over. That's but regardless, it's going to flip over that line. and then points reflected over an axis. This one you don't have a graph. You got to think about it. And it looks like, well, sometimes it might have you reflect twice. This one's only going to do once. It says point S is located at, let's see, -3, 2 on the coordinate plane. Point S is reflected over the y-axis to create points S, and I'm just going to call that apostrophe for now. What order pair describes the location of S apostrophe? So we've got -3, 2. It's reflected over the y. So when you reflect over the y value stays the same. That means the x value is the one we change the sign. So instead of -3, it'll be +3, and then the y value stays +2. That's all you do. Anytime you reflect over an axis, whichever axis it is, that value stays the same. The other one changes the sign. So let's go ahead and submit this, and it's correct. Guys, I know you're not going to get all these correct every time the first time. You're going to try to go too fast and all that good stuff. But take your time, think about what I'm telling you, and you shouldn't have any problem with today's lesson. The main thing for this is just practice. I probably should have gave you more problems, but I wanted to allow you to get good practice in.